All right, so for example 3, Caitlin thinks there may be a relationship between class size and student performance on standardized tests. She tracks the average test performance of students from 20 different classes and notes the number of students in each class in the table below. Is there a linear relationship between the class size and the average test score? Use the correlation coefficient R to explain your answer. So again, here's your data, right? All 20 class size or 20 classes with the class size and the average test score. So again, just like always, here's the scatter plot of what that looks like. The reason it's a good idea to look at the scatter plot instead of just doing the calculations is to just kind of see that what you're getting actually makes sense. So the first thing I would expect is my R value here is going to be negative. Okay, your slope should also be negative. If your slope is negative, your R value should be negative because they both indicate that your data is going downhill as you move to the right. Okay, or your Y values are decreasing as your X's increase. All right, so from there, we also want to kind of get an idea of what to expect for a correlation coefficient. Is it going to be a fairly strong linear correlation, or is it going to be a weak correlation? The first thing I notice is that I can see that linear trend. I can see where that line should go right through the middle of that data. And if you can see that, that's going to imply that it's going to be relatively strong, and it should kind of give you a hint as to what's coming. So again, how to actually calculate it. You want to go to the calculator. And like always, I've already typed them in just to save me some time here. But again, you hit your data key and pull that data up. Okay, so data, there it is. And second, and then we're going to hit data again. That pulls up the stats page. Click on 2 because it's 2 variable stats. Your X's are L1, your Y's are L2. And then we're going to hit calc. Again, so the average class size is 25.5. And then your average test score is a 33. Okay, so that's where those two are. And then all this other information that we don't really need. And then here's what we do care about. Here's the A, the B, and the R. So Y equals negative, scroll up just a little bit here, negative 0.73. Okay, X, and then plus 51.5. Okay, now this is one of those. Oh, that should have been a 6. Didn't round up. This is one of those where you kind of get a weird sort of scenario. Your y-intercept here doesn't really make a whole lot of sense because what's it really saying? If X is 0, so if the class size is 0, in other words, if there's nobody in the class, then the average score should be about a 51.5 or 0.6, so 52. So theoretically, this y value, this y-intercept really doesn't make a whole lot of sense other than it gives you a starting point. Okay, if there was one kid in the class, then it would be roughly 0.73 less than that, so roughly a 51. And then for every kid you add, you basically drop 3/4 of a point. Is kind of the idea here. So it really, you have to be careful with what this equation actually means. In reality, you're never going to have a class size that's, much less than say 10, right? Unless you're in a very, small private school sort of thing, in which case you wouldn't be taking a standardized test. Okay, so for general public school knowledge here, you're not really going to ever have a class size of less than 10. So X values lower than 10 don't make a whole lot of sense in this particular context. So again, the context of the problem means quite a bit in terms of what the equation represents. Okay, but still, there's your line of best fit. And then we see that our R value, our correlation coefficient, is negative 0.84. Again, if it's a negative slope, you're going to have a negative correlation value, but that doesn't really change anything. So we're still looking, where does it fall between -1 and 0? If it's close to 0, the data is super scattered and there's no correlation. There's no relationship between these two things. If it's closer to -1, it means there is a correlation. There is a strong presence of relatable data here. Okay, so apparently the bigger the class size is, the lower the overall test scores would be, and that would make sense, right? Because the more kids there are in the class, the harder it is to teach every kid, right? As well, anyway. So there is a correlation. So there is a strong negative correlation between class size and average student test scores. In other words, the more the class size goes up, the more the test scores go down. Okay, so that's the idea. That's how a negative one would look. Okay, nothing changes about how you do the work. So that should help you with 4.3.2. And then if you have any questions, make sure you ask me. Definitely want to check these out. Make sure you pay attention to how you use the calculator, guys.